Debbie. Okay, so here's the fish problem, and again, we can't blow it up, so we just have to read it. Hopefully,
Well, I have it on my screen too.
All right, so an estimate of the fish population is found by catching 150 fish, marking and returning them to the pond. The next day, 350 were caught. 10 had been marked from the previous day, so we want to estimate. So this is a ratio and proportion problem. It is also a sampling problem too. So let's see, what do we have? We have 150, 350, and 10 to work with. So there we go. So for this right here, we have two kinds of fish to work with. We have marked fish. Again. And we have total fish. So kind of like the way we set up a proportion problem back in chapter was it 6, 7.
We don't know
And
the
then,
total fish yet.
as far as that goes, we have a sample that we worked with. Let's see if I want to do this. And we have, let's see. Oh yeah, there's sample 1 and there's sample 2. Let's organize it that way. So in sample 1, my numerator is marked fish, right? 150 fish were marked, correct? Okay. Out of how many? Well, we don't know. We don't know how many were in the pond. In sample 2, we know that there were 10 marked fish out of a total of 350. And so what we're hoping is that the proportion of marked fish in our second sample matches the proportion of marked fish in the entire population. So does that make sense?
Would it simply be that they're trying to guess how many fish are in the pond?
Yes, we're trying to guess how many fish are in the pond. That was the goal here.
Multiply 350 by 50.
So do you get why I'm setting up the problem this way? Does that make sense now? So we have marked fish and we have total fish. We found in our second sample there were 10 marked fish out of 350. We know we marked 150 out of however many live in the pond. And that's what this question mark represents, how many live in the pond. And so solving this proportion will give us the answer we want. So cross multiply and divide, and see what we get. So whip out those calculators or do some arithmetic. A little arithmetic over here. We get the 150 times the 350, and then we're going to have to divide by 10. So whatever 15 times 350 is, let's say I could do it with multiplication. So I'm getting in the column there are backwards 3, 4, that to be there. 5,250.
Yeah.
So I believe there could be 5,250 in the pond if these ratios are equal, if they're in proportion. So as you see how this is a simulation, we can't check all of the fish, but we could do this procedure a few times and get a better estimate. Right? They're just doing it once, but we could repeat this a few times and get a more. So it's 5,250. Ooh, we got a fantastic. That's good.
I like when this stuff like that makes me feel like,
Yeah, the next
I
one.
know.
Okay, so let's see. Let's do another one of these just for fun. Similar exercise. All right, so here, let's see, they first found and marked 100 fish. and put them back. The next day, they grabbed 450, and they found 25 of them were marked from the previous day. So see if you can come up with the answer for this one.
What was the second numbers?
100 were marked the first day. The second day, they grabbed 450, and 25 of them were marked. Right on that screen. Have an answer, 1800. I guess I should do it in C.
450 times 450.
I get 1800 too. So just double checking. So in the pond, there's 100 marked fish out of a total we don't know.
Well, I have 60.
Okay. Do you have the same numbers?
I have 100 of the question mark and then 25 over 400.
Oh,
450.
if this is 450, yeah. So yeah, you would have been right with 400 though.
Okay,
Yes, you have the procedure correct.
okay.
Yeah, so again, the procedure is marked over total. Pond versus sample.
Oh, my God. So,
I wish I would have brought my
Copy the
notes
problem.
to see what I was doing. I don't remember, but it was like.
Yeah, so the thing that helps me to do these kinds of things is I take lots of notes and I write things down in different ways, and I try to be consistent. Like, what's a good label for this column? What's a good label for this row? Things like that.
Okay.
And sometimes it's doodling until something clicks. Oh, this looks familiar. I think it might work.
Or just when the little light says fantastic or
Yeah.
well done.
So
Similar exercise, maybe the next time I'll do that.
So I'm pretty sure I'm correct. So I'm going to type it in and check.
Unless it's multiple choice, you kind of get similar exercises. Like, what's it again?
All right, let's try another one. Random reading generator.
Oh,
Yeah, so I mentioned before, there's lots of ways to do random generation of things, and understanding a scheme and picking a scheme can be kind of tricky. So let's see if we can do this. How could you use, and some of these questions will make more sense if you read the book. So if you didn't read the book, please read the book soon. How could you use a random digit generator or random number table? Now, I didn't talk about random number tables. But I did mention random number generators, or random digit generators. Okay, so if you knew there's a 90% chance of, let's see, simulate rain if you knew 90% of the time conditions, as you have today, it will rain. So with a random number table, you just have a bunch of digits. So if you look on page 508 in the book, they have a sample of random digits. Or you could just go online and say something like random digits, a million random digits. Yeah, let's go. Or we can go to random.org, to the integer generator, which we played around with in class the other day, I remember. So here I might say I want integers from, now here we're looking at digits, right? What are our digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 digits, right? So I tell them, give me an integer between 0 and 9. And maybe I want 100 of them. Maybe I don't want that many. Column format is just to make it look pretty, and then I hit get numbers. And so here's my random digit table. So, and you can read it any way you want. Usually we read left to right, and then top to bottom. And so which digits would we signify mean rain if we want there to be a 90% chance of rain?
0 through 8.
We can do 0 through 8 means it's rain, and a 9 means it's not going to rain. Yeah, something like that. So here with this, this day it rains, this day it rains, this day it rains. Reading through all the way down. Finally over here, oh, a 9, it's not going to rain that day. So that's how you would use the random digit table to do something like that.
So will it make an equal amount of those numbers in that, or is it actually going to make a random number?
It's every time, it's like flipping a coin. You never know when it's going to be heads or tails. So here basically I have a 10-sided coin. I don't know whether it's going to be a 0 or 1 or a 2. If I do enough of them, I should expect to see as many 1s as 4s as 2s as 9s as 0s. Right? But a small sample could be biased somehow, accidental, coincidental. Just might happen. Remember we talked about the law of large numbers? Yeah. So I would only expect to see as many 4s as 1s as 2s as 0s as 9s and so on if I did millions and millions of them. I would get a flat histogram.
Yeah.
Okay. So here they say, okay, let the 9 digit represent rain and all the other digits represent no rain. Well, that's backwards, isn't it? That first option? That's more likely because there's more digits that aren't 9 that it won't rain. A random digit generator or random number table cannot be used to simulate rain. Well, anything can be used to simulate rain, or I can throw chocolate eggs around the room and simulate rain. Let's see, the digits 1 through 8 and 9 represent rain, and 10 represents no rain. Problem, 10 ain't a digit. It's a numeral made up of 2 digits. So they're messing with us there. So the only good answer is the last one. 0 through 8 means rain, 9 means no rain. Does that make sense?
Yeah.
So that's how you'd use a random number generator to do such a thing. All right, number 3. The results of a simulation of the event of tossing 2 fair coins 25 times are shown below. So here they're using the experimental version of probability. What is the simulated probability of tail-tail, or TT, where T represents a tail? So then they just want to look at this and say, how many times did TT come up? And so on mine, let's see, I've got 1, 2, 3, 4, I think 5. So you just have to carefully look at whatever you got. And my guess is each one is going to be different.
Be 5 out of whatever.
I'm getting 5 out of 25 here. That's what mine looks
That's
like.
what they want.
Yeah, just they want the experimental probability based on the table in front of you.
So 5 over 25.
Because there's 25 observations.
Sorry, that's not correct, Gary.
What? Oh, type an integer or a decimal rounded into number places. It says not. Yeah, it helps if you read the directions. Yeah. So they want me to type that that's 0.2. So it helps if you read the directions.
Question, I know that you say sometimes the system can be wrong or right and you just have to figure it out. Most of the time I've had it where it says enter the decimal of this number and then it'll only go to like 4 places and then start repeating. But many times it will change between accepting only 5 places, 3 places, or 4 places on the decimal point.
You just have to show me the specific problem to check that out.
I'll go back and try to find it.
Yeah, if you find it, I'd like to see it.
It's just like many times I have to go into the view an example to actually know how many decimal points.
They want the answer. Yeah. All right, let's check out the next one. All right, so this one is similar to the second one, I think. What's the probability of the event? I'm going to copy this and blow it up. So you can read
A group of 5 people chosen at random will have, at least 2 will have birthdays of the same month.
this text.
As long as we have the same text.
Let's see. Okay. What's the probability of the event? A group of 5 people chosen at random will have at least 2 will have birthdays in the same month. And so a random digit table is used to simulate the situation where 0, 0,
January.
through 1, 1 represent the months. Okay. All right, so then they give us a table of randomly generated digits that's supposed to help us answer this. So let's steal my version. Yours might look different. Oops, I might get it down here and blow it up. So let's just look at how to use the table to figure this out. So again, for me to do probability problems, I got to read it multiple times to try and figure out what the heck I'm supposed to be counting. And the hardest thing about probability problems is figuring out what to count when. So let's see, what is the probability of the event that in a group of 5 people, at least 2 will have a birthday in the same month? Okay, so then we just randomly, they're saying we randomly grab 5 people for situation 1. So in situation 1, were any of these people born in the same month?
No.
No. So what I'm gonna do is I'm just gonna put an X by the ones that don't, and maybe a check by the ones that do.
So if they do, you put a
So,
check.
so maybe I'll just cross it out. So that's a no. Let's see. How about this one? Nope. Next one for me. Nope. Oh,
Yes.
yeah, I got a pair right there, so that's a check. So let's
Here,
see.
next one.
6 and 6.
Let's see. Oh, 6 and 6. Yeah, good eyes.
And then 4 and 4 and 8.
4 and 8. Okay. So that's at least, right, a pair. There's more than one pair. Here we got a bunch. At least a pair. 8s. 1, 2, and 1. 1s. Okay. So I have 10 rows, right? 1, 2, 3, 4, 5, 6 of them had matching birth months. And so what I could say, based for my experimental probability, 6 favorable outcomes out of 10 total tries. So I would say, based on my experiment, the chance that at least 2 people have the same birth month is about 60% in a group of 5 people.
And don't reduce.
It depends on what they asked you in the little box. My opinion is when I do probabilities and I have a fraction, I don't reduce the fraction, but I do write it as a decimal, as a percentage also.
And that's for an integer or a decimal.
Yeah, so then we go back and we have to enter that properly there. And again, your numbers may be different, so we got to be careful there. Integer or a decimal. So they would want me to type 0.6. And I'm going to do a different version just to see if it's much different.
These are the decimals.
So much fun. Because decimals are easier for the computer. Yeah, they are easier for the computer, but it's a computer, we could just as easily tell it to do fractions. All right, so let me grab this table of numbers, try again, see if I get a similar answer.
Yes.
So then I'll just apply the same strategy. Looking for matches. So let's see. I got a match here, and I have a match here, and I don't think I have one there. Oh, no, I do. Yeah, there's 10s, 8s.
No. Yes.
Oh, 6 is good.
With the 0, 0 count?
See, yeah, that counts. This one does, and this one does. Okay. So it looks like we got, what, 8 this time out of 10?
Yeah.
Yeah, so it looks like there's an 80% chance or 0.8 probability that 5 people share the same birth month. And so sometimes when the probability can't be figured out theoretically, we run simulations like this over and over and over again, trying to estimate an answer. If this were on a spreadsheet, the spreadsheet has a command to look for similar things. I would use it to find them because humans are fallible. I can miss things easy. But this is just helping us get those procedures down for simulating things when we can't actually do it. All right. let's take a look at, does anybody have any questions on activity 6 simulations?
I haven't started it
I
yet,
haven't started them, so let's take a quick peek.
so it looks like we need that.
Debbie online yet? I don't think so. And you can get fake dice on your computer.
Can I?
Yeah, just type random dice in.
And it'll pop up?
It'll pop up. Yeah, there's lots of websites that do random dice. It's fun.
While I'm doing that, next week, we only have to come to class on Wednesday. So Monday, can I do the video camera deal?
Yes.
And just
And-
remind me one more time, I go to the website, the BMCC login to math, and then it's that little,
How do you connect?
yeah,
You have to go to your,
I'm on Google,
you have to go to your Google Gmail,
okay,
and when I invite you, a
gotcha,
little thing will pop up.
okay. I
So,
knew it was
but-
something would pop
But
up,
for some reason, when I type in your address, it doesn't recognize you. So if you could email me,
okay,
well, actually, give me here's what we'll do right now.
She
I'll
has to
email you and then
download
you
that
email me
app,
back.
Doesn't she? Because that's what I have to.
Oh, it depends. Like on the Mac, you would have to, on like the Windows version of Chrome, you don't have to download the app.
well, and I won't be on this, I'd be on my computer at home.
Is it a Windows computer or what kind of laptop?
It's a Windows. It's
Okay,
not-
then you might not need an app. It kind of depends on what version of Chrome you have. So let's see, I'm gonna go to my Gmail.
Because we are giving a homework day, and I'm not gonna deny, I probably won't get out of my sweatpants and shop all day, I'll probably just be.
So tell me
That's what I did today, I just got dressed.
address, what's your address again? The Gmail one?
HERRERA, two, @eou.edu. And then I don't know Wednesday, are we there all,
Yeah, I don't know how we're gonna do that.
Wednesday next week, we might be over there until, they said until we're done, so I don't think we're gonna get done by 3.
We might be late.
Yes.
We're just gonna have to go over the cycle.
Do you want me to email you back that I got it, or just?
Email me, if you can either do that now or the day of.
Okay, gotcha.
The day of would be better, a reminder
Okay.
saying, hey Parker, remember to invite me at this
Okay,
address.
don't forget about me.
Yeah.
Okay,
Because for some reason, when I start typing Debbie's name, she pops up.
gotcha.
If I start typing Minerva's, hers does, but for some reason yours doesn't, and I'm not
I
sure
don't
why.
have you blocked.
I haven't blocked you.
No, it was the last name thing, wasn't it?
I don't know if it's a different last name thing. I think it
It could be, because that was my married name when
it might be that Debbie and Minerva have accepted my invitations to do the Google Chat. Maybe you haven't
Well, I
accepted it
hadn't downloaded that app
first, and then it
first, but
worked.
then I could accept it.
Okay. All right, so let's see, what are we gonna do? Oh yeah, I wanna take a look at that,
and you said random dice on,
just type random dice in a web browser and you'll find some good options. I use a website called random.org a lot, they have great stuff.
Gary,
Yep.
a few things we gotta take care of and things.
Okay, so I'm gonna go over the simulation and then I'm gonna go over a little bit of odds and expected value in section 4. Expected value, section 4.
Okay.
So read section 4 and then you can check out my YouTube playlist for the
And I'll email you for a link to the playlist then, or you post
It's
it?
on the website in the announcements.
Right.
Just look in there.
Thank you.
All right, so activity 6. We in class already did the second simulation. I just disguised it into the Albertsons game. So here it says there's a cereal box, and inside the cereal box are 4 music trivia cards. And you want to figure out how many boxes of cereal you would have to buy in order to get all 4 cards. And so you need to run a simulation to do that. And so they give you instructions on how to do it. It's basically the same thing we did in class.
That's when you posted.
Gotcha. With
That's the one I posted
Safeway?
data for.
I wonder
Yeah.
why you posted that.
That's why I posted that one, because you could use it for that.
That's the
Um,
Safeway card.
That's the
one,
Safeway
right?
card. Yeah, this is
Gotcha.
identical to Safeway card simulation. So what I want to go over is I want to go over the Maid, Marion, and Robin Hood one, and go over an alternate way of doing it besides the dice that they suggest here. So I'm going to blow this up a little bit and we can talk about it. Oops. Okay. So Robin Hood and Maid Marian are having an archery contest. And the way the game works is they take turns shooting at a target. The first person to hit it wins. And so that's interesting. So that it keeps going until someone hits the target. The probability that Robin Hood hits it is 1/3. The probability that Marian hits it is 2/5. So Robin Hood has like a 33 1/3% chance, and Marian has a 40% chance. So Marian's a better shot than Robin. Okay. Since Marian is the better archer, Robin gets to shoot first. So the question is, because he gets to go first, is he now have an advantage even though she's a better shot? And that's what we're going to try and answer here with the simulation. Okay, we're going to try and answer that question. So here's the suggested way to simulate it. Roll a 6-sided die. Well, let's think about that for a minute. Let's see, the 1/3 chance. So that works out, if we roll a 6-sided die, if we get, let's see, 1/3 is the same as 2 out of 6. So maybe if we roll a 1 or a 2, then Robin hits it.
So make our dice 6-sided.
So that's what they're suggesting here. And then if, let's see, the probability that Marian hits is 2/5, okay? So then we could say if it's a 1 or a 2, she hits it. If it's a 3 or a 4 or a 5, she misses it. And if it's a 6, we roll the die again. Because we're trying to simulate 2/5. Does that make sense? Read through that second part of this step 1.
That just doesn't seem fair.
Well, think about it. So what's her chance of hitting? Well, it's 2/5, right? Which part doesn't seem fair?
Oh, no, I'm just, because if she hits the target, 3, 4, 5, she misses, but he just doesn't hit 1 or 2, he's out.
So yeah, so he gets 1 or 2, it's a hit. If he gets 3, 4, 5, or 6, he misses. On Marian, if it's a 1 or a 2, she hits. 3, 4, or 5, she misses. If it's a 6, we make believe we didn't roll and we try again. Because she has a 2 out of 5 chance, and there's 6 numbers on the dice, so basically we have to ignore one of the numbers for that to work. So an alternate way to do that would be on a spreadsheet with a random number generator. Because with a random number generator, we can generate any numbers we want. We don't have to have extraneous numbers. So we're going to take a look at this 2 different ways. I'm going to have you roll some dice, and then I'll show you my spreadsheet after. So what I want you to do, so here's the way it's going to work when you do this. You're going to have to take notes on a piece of paper, and then after you can use it to fill out this table. So this table doesn't keep track of all of your information. You're going to have 2 sets of things to write down. This table is a summary of what happens. So I'm just going to demonstrate it with my random number generator.
Are you going to use random dice roller?
I'm going to use a random dice roller first to show how they're using it here.
That's we're only rolling 1 dice at a time.
We're only rolling
Mine's
1
rolling 6 at a time.
at a time.
Go to random.org and use the dice roller, and you can tell it how many.
You can tell it how many to do, yeah.
So then when I said 6, I thought it meant 6-sided, but it really was saying 6 at a
6
time.
dice.
They're
Yeah.
basically playing Yahtzee then.
Yeah,
Gotcha,
so-
okay, so I need 1 for that one.
Yeah.
Gotcha.
Oh, that's weird. Their search is not working.
Okay. Next. I got that. That's how I did it.
Random.org, and then it'll say dice. Or when you do the
So
search
Robin's-
engine.
So who goes first?
random.org,
Or that's what we're trying to do.
Robin always gets to go first, so let me set my screen up for this to work here.
So Robin, we've got 2 columns, we've got Robin. Robin rolls with Mary. The only thing that's good for Robin is number 1 or 2.
Yeah, so here's the way it would work. Robin gets to go first. Yeah, good. So Robin gets to go first. So I'm just going to write down Robin and Marion. And I'm going to make, I'll worry about their other table later. So Robin rolled a 3, so that means he missed. And so now Marion rolls, so it's Marion's turn. So Marion goes, and it looks like I got a 3 again, and the 3 for Marion is that she misses also. And then Robin gets to go again. So I go back here, and I roll again, and I get a 5. And so 5 is a miss. So it's possible for this to go on for a while. And you could, like, Adrian said she had a whole bunch of dice up at once. You could have a ton of dice and just go alternate, Robin, Marion, Robin, Marion,
Well,
Robin,
could you
Marion.
put 2 dice
Totally
at the
do it that
same
way.
time side by side?
And have one be Robin, one be Marion, and do it both at once? You
Yeah.
could do it that way too, yeah. So there's tons of ways to run this simulation. We just gotta follow the rules either way. Right, so I could go back and do it that way. I could say, give me 2 dice so I can see them both at the same
Left side
time.
is Robin, right side is Mary.
Yeah. So I'm gonna ignore the Robin. I'm gonna say we got a 3 again here, so that's a miss. And then I click roll again.
So for both of them, the only thing that hits is the 1 or 2.
Yeah. And so here I got a 4, so Robin missed, but Marion hit. So this is a 4, miss, and this is a 1, which is a hit. So now this round is over. Marion just won. So what's the information I need from this? Well, I need to know that it took 1, 2, 3, 4, 5, 6 turns before somebody finally won.
Wait, 1 hit consists of a win?
That counts as a win. So this round is done. Marion just
Oh,
won.
well, what if Robin hit, like right on the first one?
Well, yeah, so it can happen different ways. So suppose I roll again and Robin gets a 2. That's a hit. Marion doesn't even get a chance to go, and then Robin wins.
Oh, okay, so,
So the trial is actually
So a trial is however many times it takes for somebody to win.
a hit.
Yeah, and there's lots of ways you can note it.
A hit.
A hit.
so then that's not fair, because Robin, if he gets a hit on the first, because he gets to roll first, then he automatically wins.
Well, we don't know it's not fair yet.
Oh,
It's just your
I'm-
belief.
I'm claiming that.
You're
because
claiming
my
it's true. So
Robin,
you have a
he kicked ass.
hypothesis that he's going to win, but we don't know that for sure.
Oh, no,
So on the 2 ones that I did, Robin won on the first try.
yeah, Robin won 3 times in a row on the first try, so that's why I'm saying it's not fair.
Well,
And
in
then-
mine, Marion won after 6 tries. Robin won in the first. My third trial, Marion missed. Robin missed. Marion hit. So I have Marion winning more. So
I think it's because I was talking smack about
here's
Robin.
the other thing. How many times do I have to do this to be sure?
They said 30.
Well, since it's experimental, the law of large numbers comes into play. What's a large number? Well, it could be a billion. It could be more than that. Right? We don't really know. So they said do it at least 30 each. All right, so you guys keep rolling. I'm going to set up a spreadsheet to do this, and then we'll compare notes. Sorry, Debbie, if you're on that in the future. Getting by mine now.
Oh, Robin's just like clean house. Oh, I gotta spell something wrong.
So I have a couple of sets of data to look at here. Okay, look, we're back. All right, so stop this transmission and I'll start you in 1 minute.